Hello class, this is Dr. Tipton. The purpose of this video is to show you yet another trick we can do to tweak or improve performance for a Rankine cycle. Now in the last class we ended discussing limitations of realism on cycle performance, and specifically turbines. We saw from the reading in section 8.3, I believe, that turbines need at least 90% quality or higher at their exits. Otherwise, you have unacceptable wear on the turbine blades from impinging water droplets acting on them. So one trick to try to increase performance and increase the vapor quality at the exit of a turbine is through reheat. This also connects well with the homework assignment you had last week that analyzed two turbines. Okay, let's zoom in and look at the turbine here, since this is the only thing that's different in this example. So we have, and I'll put a control volume around what this is calling the high pressure turbine. And it's still a turbine, so we still have rate of work of the first turbine being produced onto that shaft. We have superheated steam coming in, and this is where it gets different. Instead of having the exit steam of the high pressure turbine feeding into the low pressure turbine, we have that steam come out. So this is mass flow rate at state 2, and then that feeds back in to our steam generator or our boiler. And this becomes another heat exchanger, if you will. So the fluid goes back into our boiler, our steam generator, as a heat exchanger. It picks up more thermal energy. So we have mass flow rate at state 2 coming in. We have heat transfer, rate of heat transfer in from our steam generator device, and then coming out we have the same mass flow rate at state 3, and then that becomes the inlet to what this is calling our lower pressure turbine. So I'll put a separate control volume around that. Here's the rate of work output from the second turbine, and we call both of those together the total rate of work done by the turbine system. So that's just work of turbine 1 plus the work of turbine 2. And then exiting that turbine is mass flow that then goes to the condenser. If I look at this on a TS diagram, what I've done, let's look up here at the turbines. Instead of, if I had one turbine, I would go from my superheated state and I would drop down, ideally, isentropically, all the way down here, which this is calling 4 prime. And note that that would be a lower quality state than what I would have with reheat. With reheat, my high pressure turbine would drop to some intermediate pressure. I'll label that here. Intermediate pressure. And then at that intermediate pressure, which is a variable that you set, I go back in to the steam generator, I increase the energy level of my fluid to a new state, and then I drop through my second turbine. And hopefully it becomes evident that the exit of the first turbine is, in this case, it's superheated. It goes back to even more superheated at the inlet to the second turbine, and then the outlet of the second turbine is at a higher quality state than what it would have been if we had just one turbine. Okay, next we're going to work a specific example.